What if I told you that right now, as you're watching this video, there's another version of you in a parallel universe who chose not to click on it, and another version who's living a completely different life, perhaps one where you became an astronaut or a chef or never liked science fiction, doesn't it? Even existed at all. It sounds, but according to some of the most brilliant minds in physics today, this might not be fantasy at all. It might be the most profound truth about reality itself. Some bubbles might be nearly identical to ours, while others could be so alien that life as we know it couldn't exist there at all. But the multiverse isn't just one theory. It's actually a collection of different ideas that all point toward the same mind-blowing conclusion. There's the quantum multiverse, where every possible outcome of every quantum event actually happens, just in different realities. There's the inflationary multiverse, born from the rapid expansion of space itself in the moments after the Big Bang. There's the string theory landscape, where the fundamental fabric of reality can be configured in an almost infinite number of ways. Each of these approaches arrives at the multiverse through completely different paths, yet they all suggest the same thing. We are not alone in the cosmic sense. Now, let me blow your mind even further. If these theories are correct, then the multiverse isn't just big, it's infinitely big. And in an infinite multiverse, everything that can possibly happen must happen, not just once, but an infinite number of times. That means there are infinite versions of you reading this right now. Some are nearly identical, perhaps wearing a different coloured shirt. Others are radically different, living in universes where the laws of physics work completely differently. This brings us to one of the most profound questions in all of science. Why does our universe seem so perfectly fine-tuned for life? The fundamental constants of physics, things like the strength of gravity or the charge of an electron, appear to be set with incredible precision. Change any of these values by even the tiniest amount, and stars wouldn't form, atoms wouldn't hold together, and life as we know it would be impossible. For decades, this fine-tuning has puzzled scientists. Is it just an incredible coincidence? Evidence of some kind of design? Or is there something deeper going on? The multiverse offers an elegant solution to this puzzle. If there are infinite universes with every possible combination of physical laws, then, of course, some of them would have the right conditions for life. We don't observe the multiverse from some neutral perspective. We observe it from within the one universe that happens to support our existence. It's a bit like a lottery winner being amazed at their good fortune, not realizing that someone had to win eventually. But here's where things get really interesting. The multiverse isn't just about explaining why our universe is the way at Island. It's about fundamentally changing how we think about existence itself. If infinite realities exist, what does that mean for concepts like identity, free will, and the meaning of life? If every possible version of your life is playing out somewhere in the multiverse, are you really making choices, or are all choices being made simultaneously across infinite realities? These questions might seem abstract, but they have real implications for how we understand ourselves and our place in reality. Some physicists argue that the multiverse actually enhances the meaning of life by showing us that every possibility is explored, every story is told. Others worry that it makes our individual choices and experiences meaningless in the face of infinite repetition. Welcome to the mind-bending world of the multiverse, where everything you thought you knew about existence gets turned completely upside down. I'm talking about a concept so revolutionary, so fundamentally reality-altering, that it challenges the very foundation of what it means to be human. And here's the kicker. Some of the world's leading physicists don't just think it's possible, they think it's inevitable. The scientific community itself is deeply divided on these questions. Some researchers embrace multiverse theories as the natural consequence of our best understanding of physics. Others reject them as untestable speculation that crosses the line from science into philosophy. This debate isn't just academic. It goes to the heart of what science is and how we can gain knowledge about reality. What makes this debate even more complex is that the multiverse might be fundamentally unobservable. How do you test a theory about realities that exist beyond our cosmic horizon? How do you gather evidence for something that, by definition, we can never directly interact with? These challenges have led some scientists to question whether multiverse theories can even be considered scientific in the traditional sense. Yet despite these challenges, evidence continues to accumulate from multiple directions. The cosmic microwave background radiation, the afterglow of the Big Bang, might contain subtle signatures of collisions between bubble universes. Quantum computers are achieving feats that seem to require computational resources beyond what should be available in a single universe. String theory, our best attempt at a theory of everything, naturally leads to multiverse scenarios. Perhaps most intriguingly, the mathematics of quantum mechanics, the theory that describes the behavior of matter and energy at the smallest scales, seems to demand infinite parallel realities. Every time a quantum particle faces a choice, every possible outcome occurs, each in its own branch of reality. This interpretation, known as the many worlds theory, suggests that the multiverse isn't just possible. It's an inevitable consequence of the quantum nature of reality itself. But we're just scratching the surface of this incredible story. The deeper we dig into the science behind the multiverse, the more extraordinary it becomes. From the mind-bending implications of eternal inflation, to the revolutionary insights of string theory, from the cutting-edge experiments that might detect other universes, to the profound philosophical questions that arise when we consider infinite realities, we're about to embark on a journey that will challenge everything you thought you knew about existence itself. The story begins in the 1950 seconds with a young physicist named Hugh Everett, who was grappling with one of the most puzzling aspects of quantum mechanics. You see, quantum particles don't behave like the objects we encounter in everyday life. Instead of having definite positions and properties, they exist in what physicists call superposition, essentially being in multiple states simultaneously until they're observed or measured. It's like a coin that's spinning in the air, neither heads nor tails, but somehow both at once. The traditional interpretation of quantum mechanics, known as the Copenhagen interpretation, suggested that this superposition collapses when observed, forcing the particle to choose a single state. But Everett had a radical idea. What if the superposition never actually collapses? What if every possible outcome of every quantum event actually occurs, but in separate parallel realities? This was the birth of the many worlds interpretation, and it opened the door to perhaps the most extraordinary vision of reality ever conceived. Now, before we dive headfirst into this rabbit hole of infinite realities, let me tell you why this matters to you personally. If the multiverse is real, and I mean really real, then every decision you've ever made, every path you didn't take, every what if that's ever kept you up at night, actually happened somewhere. That job interview you bombed? You aced it in another universe? That person you never asked out? You're married to them in countless other realities. Picture this. Every quantum interaction in the universe, and there are countless trillions happening every second, creates a branching point in reality. Each branch represents a different outcome, a different possible universe. Over time, these branches multiply exponentially, creating an infinite tree of parallel realities. In one branch, you decided to have coffee this morning. In another, you chose tea. In yet another, you skipped breakfast entirely. Each decision, each quantum event, each random occurrence spawns countless new realities. But here's what makes this truly mind-boggling. We're not just talking about big, obvious choices. Every single subatomic particle in your body is constantly undergoing quantum interactions. Every photon of light hitting your retina, every neuron firing in your brain, every molecule of oxygen you breathe is creating new branches in the multiverse. The number of parallel realities being generated every instant is so vast it defies human comprehension. This brings us to an absolutely staggering realization. If the many worlds interpretation is correct, then right now, as you're processing these words, there are versions of you experiencing every possible variation of this moment. There's a version where you pause the video to grab a snack, another where you're taking notes, and countless others where your attention drifted to something else entirely. Each of these versions is equally real, equally valid, equally you. Now, you might be wondering, if all these parallel realities exist, Why don't we experience them? Why do we only perceive one continuous timeline instead of the infinite branching chaos of the multiverse? The answer lies in what physicists call decoherence. Think of it like this. Imagine you're in a crowded room where everyone is having different conversations. You can only focus on one conversation at a time, even though all the others are happening simultaneously around you. Similarly, your consciousness, your awareness, follows one particular branch of reality while remaining blind to all the others. This concept becomes even more fascinating when we consider the role of consciousness itself. Some interpretations suggest that consciousness might be the key to understanding how we navigate this multiverse of possibilities. Perhaps our minds are like surfers riding the waves of probability, experiencing one particular path through the infinite ocean of potential realities. But the many worlds interpretation is just one piece of the multiverse puzzle. While quantum mechanics gives us infinite realities through branching timelines, cosmology approaches the multiverse from an entirely different angle. This is where we encounter the mind-bending concept of eternal inflation, a process that might be generating new universes every fraction of a second since the beginning of time. To understand eternal inflation, we need to go back to the very beginning, to the first moments after the Big Bang. During this period, space itself underwent a phase of incredibly rapid expansion, growing faster than the speed of light. But here's the crucial insight. This inflationary expansion might not have stopped everywhere at the same time. While inflation ended in our region of space, allowing matter and energy to condense into the universe we know, it might have continued in other regions, creating separate pocket universes within an ever-expanding cosmic foam. The implications are absolutely staggering. Imagine blowing soap bubbles, where each bubble represents a universe. As you keep blowing, new bubbles form, while existing ones continue to expand. In the cosmic version, each bubble universe could have completely different physical laws, different fundamental constants, even different numbers of dimensions. Some might be dominated by dark matter, others might have no matter at all. Some might experience time differently, while others might exist in states we can't even imagine. The implications of eternal inflation are absolutely staggering. If this process has been ongoing since the Big Bang, then new universes are being created constantly, each potentially harboring its own forms of matter, energy, and perhaps even life. Our observable universe, everything we can see with our most powerful telescopes, would represent just one tiny bubble in an infinite cosmic ocean. This connects to one of the most profound mysteries in physics. Why do the fundamental constants of our universe seem so perfectly calibrated for the existence of complexity and life? The strength of gravity, the mass of the electron, the rate of cosmic expansion, all of these values fall within incredibly narrow ranges that allow stars to form, planets to orbit, and chemistry to create the building blocks of life. Change any of these constants by even a tiny fraction, and our universe would be a sterile wasteland. For decades, this apparent fine-tuning has sparked intense debate. Some see it as evidence of design, others as an extraordinary coincidence. But the multiverse offers a third possibility. If there are infinite universes with every possible combination of physical laws, then some of them would inevitably have the right conditions for complexity to emerge. We don't observe the multiverse from some neutral perspective. We observe it from within the one bubble that happens to support our existence. This is where the anthropic principle comes into play. It's not that the universe is fine-tuned for us. Rather, we exist in the universe that happens to be fine-tuned. It's a selection effect, like survivors of a plane crash marveling at their good fortune while forgetting about all the flights that ended differently. In a multiverse of infinite possibilities, observers like us could only exist in the universes that have the right conditions for observers to exist. But perhaps the most exotic pathway to the multiverse comes from string theory, humanity's most ambitious attempt to understand the fundamental nature of reality. String theory proposes that the basic building blocks of the universe aren't particles but tiny vibrating strings of energy. These strings exist in a space with more dimensions than the three we experience, and the way these extra dimensions are configured determines the laws of physics we observe. Here's where it gets truly mind-bending. There might be an astronomical number of ways to configure these hidden dimensions. Some calculations suggest there could be more possible configurations than there are atoms in the observable universe. Each configuration would correspond to a different set of physical laws, a different type of universe. This vast landscape of possibilities provides yet another pathway to the multiverse, suggesting that our reality is just one small valley in an incomprehensibly vast mountain range of possible realities. The convergence of these different approaches, quantum mechanics, cosmic inflation, and string theory, all pointing toward multiple realities, is what makes the multiverse so compelling to many physicists. It's not just one theory suggesting infinite universes, it's multiple independent lines of evidence, all converging on the same extraordinary conclusion. But here's what makes this even more incredible. We're not just talking about philosophical speculation anymore. We're talking about cutting-edge science backed by some of the most advanced technology humanity has ever created. Just recently, Google's quantum computer called Willow accomplished something so extraordinary that it's forcing physicists to seriously reconsider the nature of reality itself. Yet this convergence also highlights the profound challenges facing multiverse research. How do you test theories about realities that might be fundamentally beyond observation? How do you distinguish between mathematical possibilities and physical realities? These questions push science to its very limits, challenging our understanding of what it means to know something about the universe. Some researchers are exploring ingenious ways to search for evidence of other realities. They're looking for subtle signatures in the cosmic microwave background radiation that might reveal collisions between bubble universes. They're studying the behavior of quantum systems for hints that parallel realities might be influencing our own. They're even investigating whether the computational advantages of quantum computers might provide indirect evidence for the many worlds interpretation. But before we dive deeper into these mind-bending possibilities, let's pause for a moment and consider what this all means for you personally. Because here's the thing that most scientists don't talk about when they discuss the multiverse. If these theories are correct, they fundamentally change how we should think about our own lives, our choices, and our place in existence itself. Think about the last major decision you made. Maybe it was choosing your career, deciding where to live, or even something as simple as what to have for lunch today. In a single universe reality, that choice defines a path not taken, a road that disappears forever into the realm of what if. But in a multiverse, every path is taken, every choice is made, every possibility is explored. This creates what philosophers call the multiverse paradox of meaning. On one hand, if every possible version of your life exists somewhere in the infinite expanse of parallel realities, does any individual choice really matter? If there's a universe where you became a doctor, and another where you became an artist, and countless others where you chose every conceivable path, what significance does your particular journey hold? But here's where the paradox flips on itself. Some argue that the multiverse actually makes our choices more meaningful, not less. Because while every possibility might exist somewhere, you only get to experience one timeline. Your consciousness, your awareness, your subjective experience of being you is unique to this particular branch of reality. The version of you that chose to watch this video right now is having a completely different experience from the version that decided to go for a walk instead. This brings us to one of the most fascinating aspects of multiverse theory, the question of quantum immortality. It's a concept that sounds like science fiction but emerges naturally from the many worlds interpretation. The idea is this: if every possible outcome of every quantum event occurs in some parallel reality, then there must always be branches of the multiverse where you survive any potentially fatal situation. From the perspective of your continuing consciousness, you would always find yourself in the timelines where you lived, no matter how improbable your survival might seem. Now, before you start taking unnecessary risks, let me be clear, this doesn't mean you're actually immortal in any practical sense. The vast majority of timelines would still lead to normal lifespans. But it does raise profound questions about the nature of identity and continuity across infinite realities. If there are countless versions of you living slightly different lives, Which one is the real you? Or are they all equally real, equally valid expressions of your existence? This machine completed a calculation in 5 minutes that would take the world's fastest supercomputer longer than the entire age of the universe to finish. How is that even possible? Well, according to some scientists, the only way to explain it is if the computer is somehow borrowing computational power from parallel universes. These questions become even more complex when we consider the implications of advanced technology in a multiverse setting. If parallel realities exist, could we ever find ways to communicate with them or even travel between them? Some physicists have speculated about exotic possibilities like wormholes connecting different bubble universes or quantum tunneling effects that might allow information to leak between parallel worlds. Here's where things get really wild. Remember Google's Willow quantum computer that I mentioned earlier? The one that performed calculations in minutes that would take classical computers longer than the age of the universe? Some researchers interpret this as evidence that quantum computers are literally borrowing computational power from parallel universes. Every time the quantum processor explores multiple possibilities simultaneously, it might be tapping into the vast computational resources of the multiverse itself. If this interpretation is correct, then we might already be interacting with parallel realities in subtle ways, even if we don't realize it. Every quantum computer that achieves quantum supremacy, every experiment that harnesses quantum superposition, might be reaching across the boundaries between worlds to access the collective power of infinite realities. But quantum computing is just the beginning. As our understanding of multiverse physics advances, we might discover entirely new technologies based on these principles. Imagine computers that could solve problems by consulting infinite parallel versions of themselves, communication systems that could transmit information across dimensional boundaries, energy sources that tap into the vast resources of the multiverse itself. Of course, these possibilities remain highly speculative, but they illustrate how multiverse theory isn't just an abstract concept for physicists to debate in academic papers. It has the potential to revolutionize technology, philosophy, and our understanding of what it means to exist in this strange and wonderful cosmos. Yet for all these mind-bending implications, perhaps the most profound impact of multiverse theory lies in how it changes our perspective on human significance. For centuries, scientific discoveries have seemed to diminish humanity's place in the universe. We learned that Earth isn't the center of the cosmos, that our solar system is just one among billions, that our galaxy is merely a speck in a vast expanse of space and time. The multiverse continues this trend of cosmic humility, suggesting that our entire observable universe might be just one bubble in an infinite foam of realities. But it also offers a strange kind of comfort. In a multiverse of infinite possibilities, everything that can happen does happen. Every story gets told, every dream gets realized somewhere, every tragedy has a parallel where it's averted, every loss has a counterpart where it's prevented. This doesn't diminish the reality of suffering or joy in our particular universe. Your experiences, your relationships, your achievements and failures are no less real or meaningful because parallel versions exist elsewhere. If anything, the multiverse reminds us that consciousness itself is the most extraordinary phenomenon of all. Out of infinite possible arrangements of matter and energy, only a tiny fraction give rise to awareness, to the subjective experience of being someone rather than no one at all. I know what you're thinking, this sounds absolutely insane. And you're right, it does. But that's exactly what makes it so fascinating. Throughout history, the most revolutionary scientific discoveries have always seemed impossible at first. The idea that the Earth revolves around the sun, that germs cause disease, that time can slow down depending on how fast you're moving, all of these concepts were once considered laughable. The fact that you exist, that you can contemplate these ideas, that you can wonder about your place in the cosmic order, remains absolutely remarkable regardless of how many universes might exist beyond our horizon. In a sense, every conscious being is a unique window through which the multiverse experiences itself, a singular perspective that will never be exactly repeated, even across infinite realities. This perspective becomes even more poignant when we consider the possibility that consciousness itself might play a fundamental role in shaping reality. Some interpretations of quantum mechanics suggest that observation, measurement, and perhaps even awareness itself influence the behavior of quantum systems. If this is true, then conscious beings like us aren't just passive observers of the multiverse. We might be active participants in determining which branch of reality we experience. Think about that for a moment. Every observation you make, every measurement you take, every conscious choice you experience might be helping to navigate the infinite tree of possibilities that make up the multiverse. Your awareness isn't just along for the ride. It might be one of the fundamental forces that determines which particular slice of infinite reality you get to experience. But as we explore these incredible possibilities, we must also grapple with the profound challenges they present to science itself. The multiverse pushes us to the very limits of what can be known, tested, or verified. How do you design experiments to detect universes that might be fundamentally beyond observation? How do you distinguish between mathematical possibilities and physical realities when dealing with concepts that transcend our observable horizon? These challenges have sparked intense debates within the scientific community. Some researchers argue that multiverse theories represent the natural evolution of our understanding of reality, the inevitable conclusion we reach when we follow our best theories to their logical endpoints. Others worry that we're crossing the line from science into metaphysics, abandoning the empirical methods that have made scientific progress possible. This tension reflects a deeper question about the nature of scientific knowledge itself. Is it enough for a theory to be mathematically elegant and logically consistent? Or must it also make testable predictions about observable phenomena? Can we accept the existence of realities that we can never directly verify? Or does science require the possibility of falsification through experiment and observation? As we stand on the brink of potentially discovering whether we truly live in a multiverse of infinite realities, these questions become more than academic curiosities. They go to the heart of how we understand truth, knowledge, and our place in the grand scheme of existence. The search for evidence of parallel universes has become one of the most ambitious undertakings in modern science, pushing researchers to develop increasingly sophisticated methods for detecting the undetectable. And surprisingly, some of the most promising leads are coming from places you might never expect. Let's start with something that sounds almost impossibly subtle: the cosmic microwave background radiation. This is the faint afterglow of the Big Bang, a kind of fossil light that fills the entire universe. To most of us, it would seem like the most uniform thing imaginable, but to cosmologists, it's like a treasure map filled with incredibly detailed information about the early universe. And hidden within its patterns might be the signatures of collisions between bubble universes. Think of it like this: if our universe is indeed one bubble in an infinite foam of realities, then occasionally these bubbles might bump into each other. When that happens, it would leave a distinctive mark on the cosmic microwave background, a kind of circular bruise that we could potentially detect with sensitive enough instruments. Several research teams have claimed to find these signatures, though the evidence remains hotly contested. Yet here we are, living in a reality shaped by these impossible truths. It's like trying to spot a whisper in a thunderstorm, but the implications would be revolutionary. Then there are gravitational waves, those ripples in space-time that we've only recently learned to detect. When massive objects like black holes collide, they create waves that propagate across the universe at the speed of light. But if bubble universes can interact, they might also generate gravitational waves with distinctive signatures that could reveal the existence of parallel realities. It's an incredibly long shot, but researchers are actively looking for these cosmic fingerprints in the data from our most sensitive gravitational wave detectors. Perhaps even more intriguing is the growing body of research into what scientists call quantum archaeology. This involves looking backwards through quantum interactions to try and reconstruct the branching history of reality itself. Every quantum measurement leaves traces, and by carefully analyzing these traces, some researchers believe we might be able to detect evidence of parallel branches that we're not directly experiencing. But here's where things get really wild. Some physicists are exploring whether consciousness itself might provide a window into parallel realities. There are documented cases of people reporting experiences that seem to involve knowledge they shouldn't have access to, or making decisions based on information that appears to come from nowhere. While most of these can be explained through conventional psychology, a small but growing number of researchers are investigating whether some of these phenomena might represent genuine glimpses across dimensional boundaries. Now, I know what you're thinking. This sounds dangerously close to pseudoscience, and you're right to be skeptical. The vast majority of claimed paranormal experiences have perfectly normal explanations. But the point isn't that every strange experience is evidence of parallel universes. The point is that if the multiverse is real, we might expect consciousness to occasionally pick up signals from other branches of reality, especially during moments of quantum uncertainty. This brings us to one of the most controversial experiments in modern physics: attempts to create what researchers call quantum telepathy between isolated systems. The idea is that if parallel realities exist and occasionally interact, then quantum entangled particles in our universe might sometimes become entangled with particles in parallel universes. If true, this could create channels of information exchange that transcend the boundaries of our single reality. These experiments are still in their infancy, and the results are far from conclusive. But they represent a fascinating attempt to test one of the most speculative predictions of multiverse theory using rigorous scientific methods. It's the kind of research that would have been considered impossible just a few decades ago, but which now represents the cutting edge of quantum physics. Meanwhile, advances in artificial intelligence are opening up entirely new approaches to multiverse research. Machine learning algorithms are becoming incredibly sophisticated at detecting patterns in vast datasets, patterns that might be invisible to human researchers. Some teams are now using AI to analyze cosmic data, looking for signatures that might indicate interactions between parallel realities. So what exactly is the multiverse? At its simplest, it's the idea that our universe, everything we can see and touch and measure, is just one of an infinite number of universes that exist simultaneously. Think of it like this. Imagine reality as a vast cosmic bubble bath, where each bubble is an entire universe with its own laws of physics, its own timeline, its own version of you. But perhaps the most promising avenue for multiverse research lies in the rapidly advancing field of quantum simulation. As our quantum computers become more powerful, we're gaining the ability to create artificial quantum systems that mimic the behavior of the early universe. By studying how these simulated realities evolve, we might gain insights into the processes that could generate multiple universes. These quantum simulations are revealing something fascinating. Under the right conditions, what appears to be a single quantum system can spontaneously split into multiple non-interacting branches. It's like watching the birth of parallel realities in miniature, and it's giving researchers unprecedented insights into how the multiverse might actually work. So where does this leave us? Standing at the edge of perhaps the greatest mystery in all of existence, armed with equations that hint at infinite realities and experiments that might just prove we're not alone in the cosmic sense. Whether we live in a single precious universe or an infinite multiverse of possibilities, one thing remains absolutely certain: your consciousness, your ability to ponder these mind-bending questions, makes you part of something extraordinary. Every choice you make, every moment you experience, contributes to the grand tapestry of existence itself. And maybe, just maybe, somewhere across the vast expanse of parallel realities, another version of you is just as amazed by the sheer wonder of it all.